All right, welcome to Unit 2, Lesson 6. Today's lesson is going to focus on radicals, more specifically simplifying them and then performing operations with them. Okay, so let's get started. First, let's go over some of the basics. All right, this in no way, shape, or form should be new to you. Okay, if a radical contains a perfect square, it must be simplified, meaning if it has a perfect square as a factor, all right, then it must be simplified. Okay, I'm going to go through some of these rather quickly because this should be new. Let me see. Okay, we just got these three here to do. So I know that the number 25, I'm looking at number 1 here. The number 25 goes into 50. Okay, this is the same thing as saying radical 25 times radical 2. All right? And the square root of 25 is 5. I cannot do anything else with the square root of 2 to simplify it. There is not a perfect square that goes into 2. So that's my simplified form. All right. Let's look at this next one. All right. Notice how I have highlight a 2 in front. The 2 is not under the radical, and I'm just going to carry that along for the ride. So I'm going to focus right now on my radical 48. I know it's a square root of 16 times the square root of 3. And my 2 just comes along for the ride. Remember, this operation between the 2 and the radical 48 is multiplication. So basically, this is 2 times radical 48. So whatever I end up in my simplification, I need to multiply it times that 2. All right, let's keep going. I know the square root of 16 is 4. I cannot do anything with this radical 3. And I'm still going to multiply times my 2. And I do just that. 2 times 4 is 8. Radical 3. Badoosh! Done. So lovely. And now we come to the last one. And I look at the square root of 108. Okay, again, this 1/2 just comes for the ride. All right? So, I know that 36 times 3 is 108. So radical 36 times radical 3 is radical 108. That's why I can factor out these radicals. Times 1/2. Okay, I know the square root of 36 is 6. I know the square root of 3, I can do nothing to simplify it. And multiply times 1/2. 1/2 of 6 is 3. Done and done, simplified. Okay, let's step this up a notch. Okay, I have radical 98 times x to the 4th times y cubed. I'm going to tell you how I handle these things, and we'll go from there. All right, so I'm going to break. I have three this is one big term, 98 x to the 4th y cubed. But I'm going to take my big number, 98, and treat that separately. I'm going to take my x to the 4th and treat that separately under the radical, of course. And I'm going to take my y cubed and treat that separately. All right? Now, I know that 49 times 2 is 98. So I can leave those. And this ends up being 7 radical 2. Okay? Now, how do I handle my variables under the radical? So what we got to look at is the root. This is a square root right here. Right? It's a 2. If it's not written, we assume it's a 2. So what you need to do is you take the number on the inside, okay, and you divide it by the number on the outside. It's simple division. Okay? It goes in there twice with a remainder of 0. So basically, we're going to use division to help us simplify. Now, I hope you can divide single-digit numbers and figure out how many times one single-digit number can go into another and realize what the remainder is. Now, why do I divide? This here tells me how to simplify. The quotient part tells me how many, in this case it's x's, come out of the radical. And the remainder part, notice the word remainder, tell me how many x's, I'm going to use the word remain because it's similar to remainder, remain in, okay? 2 out, my remainder is 0, so 0 remain, okay? So this just becomes x squared because 2 come out of the radical, okay? Now, if you get good at this, you really don't need to set up this division or anything. You can do it quickly in your head. For example, square root of y cubed. 3 divided by 2, it goes into it once and has a remainder of 1. So 1y comes out, and 1y remains under the radical. Okay? So we have this whole board of numbers and radicals in front of us, and now it's just a point of just copying. So what I mean is the following. Everything that is outside of a radical gets lumped together outside of the radical. Ultimately, my answer will have 1 square root. Okay? So what is outside the radical? There's a 7. There's an x squared that's no longer in a radical, and there's a y. So I simply write it, 7x squared y is outside the radical. Okay? Now, what is still inside the radical? A 2 and a y. So I write 2 and I write a y. And that is simplified. Okay? So I handle my numbers just like anything else. And how do I handle the variables? I divide. Let's try a few more of these. Okay? 72. That's 36 times 2. So they're under radicals. That ends up being 6 radical 2. Good. This is a 2. Okay? So I've got a, and I'm going to do 5. I can change it to a fraction here divided by 2. 2 goes into 5 twice. So 2 comes out with a remainder of 1. So 1 remains in. You can do this quickly. Again, 5 divided by 2. It goes in twice with a remainder of 1. So 2 come out. 1 remains in. All right? Now, my b's. Okay, I have 2 divided by 2 is 1. And there's no remainder. So 1b comes out. So I have b to the 2 over 2. That's like b to the 1. That's it. Done. Of course, the c is kind of on an island by itself. That is c to the power of 1. I divide it by 2. 2 doesn't go into 1 at all, 0 times, with a remainder of 1. I can't take anything out. Meaning, if I take 1 and divide it by 2, 2 doesn't even go into 1 at all, with a remainder of 1. Okay, so that's going to stay c to the first inside the radical. So now let's just copy what we have. What do we have outside? 6, a squared b. What's inside the radical? 2, a, c. Done and done. Next one. Oh, we handle this the same exact way. We just multiply our -2 when we get to the end. So 200. That's like radical 100 times radical 2. So that's 10 radical 2. Okay. Don't forget, this is a square root. So I take 8 and divide it by 2, and I get 4 without a remainder. So I actually have m4s, m to the power of 4. 4 m's that come out. Okay. So now I take my 2, okay, and I divide that into 7. 2 goes into 7 3 times, so 3 come out, with a remainder of 1, so 1 remains in. All right? And now I write these 10 m to the fourth n cubed, right? And under the radical is 2n. But let's not forget, we still have to multiply by our negative 2. So I'm just going to multiply my 10 times negative 2. Get negative 20 m to the fourth n cubed times 2. Ooh, yeah, that's a radical, not a parenthesis. 2n. If you want to do this, you can. In fact, I would suggest that you always parenthesis off your radicals. Because just like this right here, that 3, if I have n cubed times the square root of 2n, this 3, does that mean cubed root? Does it go like this? Or is my n cubed and it's a square root? So is it like that, or is it like this? You don't know unless you write parentheses. Okay? You don't know unless you put parentheses around there. And a lot of the kids that I have, their writing is a little bit messy, and they squeeze a lot of things together. And I would highly suggest that. All right, last one. Last one. 4x. We're just going to carry along for the ride and multiply in the end. 80. What's a square root that goes into 80? I think it's 16 and 5. So it's 16 times 5. Square root of 16 is 4. 4 radical 5. Done. 2 goes into 6 3 times with a remainder of 0. So x to the 3 comes out and nothing remains in. 2 goes into 9 4 times, so 4 y's come out with a remainder of 1. So 1 remains under the radical. And 2 does not even go into 1 at all. I can't take anything out for my z. That's just going to remain under my radical. Let's put all this together. Okay? 4 x cubed y to the fourth. 4x cubed y to the fourth. And I'm going to put that in parentheses. 5yz. 5yz. Don't forget, we still need to multiply by 4x. So, when everything's all said and done, 4 times 4 is 16. X times x cubed is x to the fourth, y to the fourth, parenthesis, 5yz. A little bit detailed, a little bit of writing, but that's the easiest way to do it. Now, if you get good with this in your head, like I was starting to, you can kind of start to skip. You don't have to actually write out your division, okay? You can kind of go right from, here to here. All right? And then you, of course, still need to multiply your 4x in to get here. Like, writing this out is just me showing you my thought process. But you should write that out until you get really good at it. In fact, if this were a test, you should probably still write that out to show your work. All right? Simplifying perfect cubes. It happens the same exact way as we do perfect squares. This is really, really critical. You should know inside and out your perfect squares. The square root of 1 is 1. The square root of, 1 squared is 1. 2 squared is 4. The square root of 4 is 2. Okay? If we know our squares, we know our square roots. 3 squared is 9. 4 squared is 16, and so forth. But what I also have in this list are perfect cubes. 1 cubed is 1. That's 1 cubed. 2 cubed is 8, and so forth down this list. Now, when it comes to perfect squares, 11 squared is 121. 12 squared is 144. You should know these things. But when it comes to cubes, you should definitely know at least to 125 and up without even batting an eye. All right? If you don't know them, know them. 6 is 216, 7 is 343. I mean, maybe you'll have to deal with these on a test. I don't know. If a cube comes up on a test, all right, like we learned how to factor perfect cubes, right? X cubed minus 64. You should know that 64 is the cubed root, okay, is 4 cubes. The cube root of 64 is 4. All right? Now, I doubt they're going to say, and they might, x cubed minus 729, okay, because that would be 9. Okay, these ones here are the very common ones to use. All right, so know these things. All right, I put them on your notes for a reason. How are we doing time? Go, got 15 minutes. So let's simplify these the same exact way we did square roots. When we simplified square roots, we wanted to find squares, perfect squares, that were factors, right? Because they took care of themselves. So let me go back. If it contains a perfect square, because we were doing square roots. And that means it had to have a perfect square as a factor. So now we're doing cubed roots. So I want perfect cubes that are factors. And I still put my list right here. You might have it in front of you. I want to have it here. So I know for a fact that 27 times 2 is 54. So I can say 54 is like saying 27 times 2. But instead of keeping them under a square root, I have a cubed root, so I'm going to keep them under a cubed root. All right, and the cubed root of 27 is 3. And here is where I like you to use parentheses. You have to. For square roots, you should. You should get in the habit. But if I do this, I don't know if that's 3 cubed times the square root of 2, or if that's 3 times the cubed root of 2. I don't know where that little 3 belongs, but if I do this, I know it definitely belongs with the radical sign. And there you go. Let's do a couple more of these. This 2 comes along for the ride. So, negative 40. We can't have negatives under square roots, but we can have negatives under cubed roots. Okay? We can. If I have a negative under a cubed root, my answer, my output should be negative. All right? So, this 2 comes along for a ride. 40 is 8 times 5. All right? And I'm going to put my negative with the perfect cube. Okay, so the cube root of 8 times the cube root of 5. Why am I going to do that? Because I can take the cube root of a negative. This ends up being negative 2. All right? So how does that work? Remember, we are multiplying negative 2 times itself 3 times to get negative 8. Negative 2 times a negative 2, well, that's a positive 4. That's why perfect squares can never be negative. Even if I multiply a negative times a negative, I get a positive. But cubes, we're multiplying it by itself 3 times. The minute you introduce an odd number of factors, I could take positive 4, multiply it times negative 2, and get negative 8. All right, so that's why that works. And now this comes down, it's 2 times that, times the cubed root of 5. So I get negative 4 times the cubed root of 5. All right? So what you should be asking me is this. Mister, what if instead of putting my negative with the 8, I put it with the 5? All right, well, your answer would have been 4 times the cubed root of negative 5, wouldn't it? If my negative was here with the 5, it would have been here with the 5. It should be here with the 5, right? Think about multiplication. This is what we're doing. If I take negative 3 times a positive 2, I get 6. What happens if I switch the negative sign? And I put it with a 2. Yeah, I said negative 6 here. Probably write it. I still get negative 6. My answer will still be equivalent. It will still be the same. What you got to realize is, if this is multiple choice in the final, and you get an answer like this, but you don't see it on the multiple choice because you only see something that looks like this, you should know that that and that are the same thing. Okay? If this was short answer, either one of these would be fine. Okay? But if it's multiple choice, they're the same. It could be written one way or the other. And we're moving. Last one here. 250. 250. I think 125 goes into that. And look at that. Perfect cube. It's 5 cubed. So I'm going to take my -2, just carry that along. 125 times 2 is 250. I'm still taking the cube root of these. So this is -2 times 5 times the cubed root of 2. That one was easy. -10 times the cubed root of 2. I want that 3 with my radical sign, and I am done, man. Let's go. Oh, plenty of time. All right, so let's do a few more here, and we're going to go through these a little bit quicker. All right, and I'm going to look at 40. Well, cube, I know that's 8 and 5, right? Cube root of 8, the cube root of 5, so that is 2 times the cube root of 5. And now we're going to do this the same way we did square roots. We're going to divide. Okay, I'm looking at 7. I'm not dividing it by 2 anymore. I'm dividing it by 3. So 7 divided by 3, 3 goes into 7 twice with a remainder of 1. So I'm going to have 2 x's, x squared, come out, and 1 x is going to remain under the radical. And now I look at my y's. I take 3 and divide it by 3 and get 1 without a remainder. So I have y to the first. And now we're to the point of just grouping everything together that is outside of my radical, meaning I have 2 x squared y. In fact, I know I do this all one color, but I guess that's what we got for right now. Now let's do it. What the heck? Visuals, right? 2 x squared y. They are all outside. 2 x squared y. Then everything that's still or remaining in the radical is 5x. Okay, and that's it. So I'm going to write that, 5x. So it is done the same exact way, all right, as we did with our square roots. And we handle variables by dividing, same deal. All right, let's look at this next one. My -2 comes along for the ride. 48. 24, 16, 8. 8 times 6, right? 48 is the cubed root of 8 times the cubed root of 6. And the cubed root of 8 is 2. Okay, so we have 2 times the cubed root of 6. This -2 comes along for the ride. All right, now I'm just going to divide. 3 goes into 3 once with 0 remainders. So I have x to the 1. Done. 3 goes into 10 3 times, so 3 y's come out, with a remainder of 1, so 1 y remains under the radical. So here we go. These two, if I multiply them together, I get -4 x y cubed. Those are all outside the radical. What's inside? 6 y. And I'm going to put my parentheses. And there you go. Super de-duper. Let's do this last one. Doing good. Ooh, -192. Is that a perfect cube, 192? It is not. It shouldn't be. But what goes in 192? Not 125. Does maybe 64 times 3 is 192? I think it is. So I'm going to put my negative with my 64 times 3. Okay, cubed roots. And how come? Because I can take the cube root of a negative. I end up with -4 times the cubed root of 3. Done. Okay, 3 goes into 4 once with a remainder 1. So 1a comes out. and 1a remains in. 3 goes into 5 once, so 1b comes out, but it has a remainder of 2. So 2 remain in. Okay, again, if I take 5 and divide by 3, it goes in once with a remainder of 2. So 1 comes out, 2 remain in. Okay, same rules apply. So let's now start to pull everything out. -4 is outside. A is outside. B is outside. -4 AB. What remains in our radical? 3a b squared. 3a b squared. And that, my friends, is B, beautiful. Love it. Okay, I'm going to go over 2 more slides quick, and then we'll be done. What is the difference between -24 and the cubed root of -24? First of all, this is a square root, and I cannot have negative numbers in a square root. If I do, my negative pops out and becomes an I, square root of 24. This becomes a square root of 4 times the square root of 6, because that's 24. And the square root of 4 is 2. So my answer is 2i radical 6. So you notice it's imaginary. But if they ask you for any real solutions, if you have a negative underneath a square root, there are no real solutions. There are only imaginary solutions, okay? But when you have a negative underneath a cubed root, like we discussed earlier, you can get a negative number. Any root that is odd, you can have a negative number and get a real solution. Any root that is even, you cannot get a negative, or you cannot have a negative under there and get a real solution. It would have to be imaginary. So if we did this, that'd be the -8 times 3 cubed root, and you actually get -2 out here. So what's the difference? Negatives under the square root would be no real solution, imaginary. Negatives under a cubed root, you can get a real solution and get a negative number. All right, let's practice some of these, and I think we're going to stop here after this. Just 3 of them. I'm going to rip through them quickly. If you want to pause the video and do them yourself, go nuts. Okay. -56. I know it's -8 times 7. Okay, those are cubed roots. My 9 just comes along for the ride. This is 9 times -2. That's the cubed root of a -8 times the cubed root of 7. This is done. We'll call this -18 times the cubed root of 7. This is done. 3 goes into 8 twice. So I take 2 c's out with a remainder of 2. So 2 c's remain in my cubed root. Oh, this is nice. 3 goes into 12 4 times evenly with no remainder. So d to the power of 4 comes out. Let's figure this out. What's out? What's in? -18 is out. C squared is out. D to the 4th is out. What is in? I am in. Ha ha. 7. C squared. Oh, that it? That it? Done and done. First one done. Second one. Okay, this is a square root. First of all, I know this is no real solution. That's what I'm going to write for NRS. But we know how to handle negatives under a square root. This is 2. Okay? It's going to be imaginary. So the first thing I'm going to do is I'm going to plunk this negative out and become an I. So it's -10I radical 80. Okay? Now I'm just looking for perfect squares that go into 80, and it is 16 and 5. Okay? This is 16 times 5. That's 80, so square roots. And the square root of 16 is 4. So I've got -10I times 4 times radical 5. -40I radical 5. Done and done. Last but not least, another square root. There's no negative values underneath, and we have variables once again. So this 1/5, do this in blue. 1/5 times. All right, well, 50 is 25 times 2. Those are square roots. And this is 5. The square root of 25 is 2 times radical 2. Right, 2 goes into 4 twice with the remainder of 0. So 2 x's come out, it's x squared, and 0 remain in. 2 goes into 7 3 times, so I've got y to the 3 that's out. And there's a remainder of 1. So y to the 1 remains in. And now it's just a matter of simplifying this. Okay, 1/5 times 5 is actually 1. That's on the outside. X squared is on the outside. Y cubed is on the outside. What's still in the radical? 2y. Now, this is a good answer. If this were multiple choice, we don't write 1s as lead coefficients. So if it was multiple choice, it would be written x squared y cubed times the square root of 2y. Okay? Man, that was a lot, and you stuck with me. We're going to stop here because we're kind of done with simplifying single radicals. As we move forward, we are going to start doing operations with radicals. All right? So I'll see you next time for Unit 2, Lesson 6, Part 2. Have a good one.